In March 2026, federal agents arrested a Silicon Valley executive, not a hacker, not a fraudster, the co-founder of a $20 billion American tech company accused of helping run one of the largest smuggling operations in the world. Not drugs, not weapons, computer chips, more than $1 billion worth smuggled into China in a single year through shell companies, freight forwarders, and deals arranged on encrypted apps, people risking decades in prison for a computer part. And the strangest part? The people buying them weren't trying to play video games. They were trying to change the balance of power between nations. Because this tiny piece of silicon quietly runs civilization. Every ChatGPT answer, every Tesla, every iPhone, every bank transaction, every F-35, every missile guidance system. All of it depends on one tiny object. An object so difficult to make that most countries on Earth, with all their money and all their engineers, cannot produce a single one. In the next 15 minutes, how the most valuable object in the world is actually made, who secretly controls it, and why some people will risk everything just to move one across a border. This is the story of the AI chip empire. Every government on Earth knew AI was going to change the world. But there was one problem. Almost nobody on Earth could build the chips it runs on. Here's why. A chip is a slab of silicon smaller than a postage stamp, holding billions of microscopic switches that flip on and off billions of times per second. That's all computing is. Tiny switches, flipping. But AI needs a special kind of chip called a GPU. A normal processor is one brilliant worker, doing tasks one at a time. A GPU is an army of thousands of workers, all doing simple math at the same time. And training artificial intelligence is exactly that kind of job. So when the AI boom exploded, the world needed GPUs by the millions. And about 90% of the best ones are designed by one company, a company that started in 1993 in a booth at a Denny's diner in San Jose with 3 engineers betting that video games would need better graphics. That bet was NVIDIA. Last fiscal year, that diner startup earned more money than McDonald's, Nike, Starbucks, and Intel combined. Roughly $216 billion, making it, at times, the most valuable company on Earth. But here's the first twist. NVIDIA doesn't make chips. The most valuable chip company on Earth has never manufactured one. It owns no factories. It draws the blueprints and sends them across an ocean to be built. So how hard can it really be to manufacture a chip? Harder than almost anything humans have ever done. Every AI model you've ever used started life as beach sand, which somehow leads us to one of the biggest monopolies in history. That sand is melted and purified until it is 99.9999999% pure, 9 nines. For every billion atoms, barely one is allowed to be out of place. The silicon is grown into a gleaming crystal and sliced, like a salami, into mirror-polished discs the size of dinner plates. Each disc is a wafer, and hundreds of chips are printed onto it at once, like cookies on a sheet of dough. But the wafer isn't the hard part. The hard part happens inside a fab, a chip factory. A single fab can cost more than the entire yearly economy of a small country, can take up to 5 years to build, and its air is kept thousands of times cleaner than a hospital operating room. Because one invisible speck of dust can kill a chip that might later be guiding a plane or moving your money. Inside, the chip is printed with light, layer on top of layer, up to 1,000 layers, over 3 to 4 months per wafer. And here's the rule that drives this whole industry. The smaller you print, the more powerful the chip. Today's transistors are smaller than a virus. There is exactly one way to print something that small, and only one company on Earth ever figured out how. The crazy part? They almost didn't exist. A SML started in 1984 as a struggling spin-off working out of a leaky shed next to a Philips office in the Netherlands. Today, it builds the most complicated machine ever sold. Inside it, a droplet of molten tin is blasted by a laser 50,000 times every second, creating flashes hotter than the surface of the sun. And that's just the light bulb. That light is then bounced off the smoothest mirrors humans have ever made. So perfect that if you stretched one to the size of Germany, the tallest bump would be 1/10 of a millimeter. Each machine costs up to $400 million and ships to customers in multiple jumbo jets. IKEA furniture is easier to assemble, and ASML itself says no one alive fully understands every part of it. One company, one machine. If ASML vanished tomorrow, progress in computing simply stops, not slows down, stops. But here's the thing. Even ASML isn't the real bottleneck, because now we reach the single weakest link in the entire semiconductor industry. Spruce Pine, North Carolina. Population, about 2,000. A tiny American town whose name almost nobody knows, and it might be one of the most important places on Earth. The crucibles that melt silicon demand quartz so flawless that, by most estimates, 70 to 90% of the world's supply comes from this one town's mines. When Hurricane Helene flooded Spruce Pine in 2024, the global chip industry held its breath. Miners in Appalachia, holding up the artificial intelligence revolution. And the manufacturing itself? Around 90% of the world's most advanced chips are made by one company on one island, TSMC, in Taiwan. A company founded in 1987 by Morris Chang, an engineer in his mid-50s whose 25-year career at Texas Instruments had stalled just short of the top job. Taiwan offered him a second act, and he built what may now be the most important company most people have never heard of. The scale is absurd. TSMC drinks about 150,000 tons of water every day and consumes more than 6% of Taiwan's entire electricity. During a drought in 2021, Taiwan cut water to its farmers to keep the chips flowing, which leads to the strangest fact in this story. Taiwan doesn't just manufacture chips, it may have accidentally made itself too important to invade. Analysts call it the Silicon Shield. China needs Taiwanese chips, so does the West. The world's most valuable factories might be the island's best defense. Now step back, because this is the part that should genuinely blow your mind. Follow one single ChatGPT answer backwards. Quartz from North Carolina, mirrors from Germany, chemicals from Japan, machines from the Netherlands, manufacturing in Taiwan, design in California, financing on Wall Street, 25,000 miles, 70 border crossings, all of it, for one object the size of your fingernail. And here's the terrifying part. This isn't a supply chain with backups. Remove one piece, one town, one company, one island, and the entire system stops. No chips, no data centers, no AI. So what happens when the two most powerful countries on Earth start fighting over exactly that? Then Washington made a decision that changed the entire industry overnight. Starting in October 2022, the United States banned the export of advanced AI chips to China and pressured the Netherlands to withhold ASML's machines too. The logic was simple. Whoever has the best chips trains the best AI, and every choke point in the pyramid sits in allied territory. But here's what nobody tells you about export bans. They don't kill demand, they just change its price. The result was the black market from our opening. Prosecutors described chips crisscrossing the globe, invoiced as ordinary electronics, routed through Taiwan, Thailand, and Hong Kong, landing in mainland China at markups of 50% or more. One indicted ring allegedly moved $160 million of NVIDIA chips in under a year. The Supermicro case, the executive from our opening, allegedly involved $2.5 billion in servers. Those cases are still in court, and the accused deny wrongdoing. But NVIDIA's own position is telling. It says it cannot fully control where its chips end up once they're sold. China, meanwhile, isn't just buying through the back door. It's brute forcing its way forward. Its national champion, SMIC, makes surprisingly advanced chips without EUV machines, pushing older equipment far past its limits. Slow, expensive, wasteful, but improving every year. And Huawei now designs AI chips good enough that Beijing is ordering its tech giants to buy them. So America's wall is leaking, and China is climbing it anyway. But here's the twist. China isn't even NVIDIA's biggest problem. NVIDIA has one enemy it can't sanction, can't sue, and can't outrun: its own customers. Every company spending billions on NVIDIA chips is quietly working toward the same goal: making NVIDIA unnecessary. Google moved first. It's been designing its own AI chips for a decade. Then Amazon, whose latest chip uses cutting-edge 3-nanometer technology. Then Microsoft. Then Meta. And then, the most symbolic betrayal of all, OpenAI, the company whose chatbot started this entire gold rush on NVIDIA hardware, is now co-designing its own silicon, due this year. In 2026, these custom chips are growing nearly 3 times faster than GPUs. The rebels are coming from below, too. A startup called Cerebras asked a beautifully simple question. If chips are cut from a dinner plate-sized wafer, why cut? Their processor is the entire wafer. One chip, the size of a dinner plate with 4 trillion transistors. And behind the companies come the countries. Because every government on Earth watched the same lesson unfold and reached the same conclusion. Depending on one island for the most important object in the world is simply too dangerous. So Vietnam, better known for assembling phones, opens its first chip fab this year. India is building its first fabs. Japan is spending billions on a comeback. Malaysia is expanding the packaging plants that already handle 1/10 of the world's chips. None of them will rival TSMC soon, but they don't need to. They're climbing onto the bottom rungs of the pyramid, one layer at a time. Which brings us all the way back to a pair of handcuffs in Silicon Valley. Remember the executive arrested at the start of this video? On paper, that case is about smuggling. But really, it's about something much bigger. Because when a tiny object becomes this valuable, people don't just buy it. They build black markets for it. Companies build empires around it, and superpowers redraw their entire foreign policy for it. Every ChatGPT answer, every Tesla, every iPhone, all of it balanced on a chain that runs through a town in Appalachia, a campus in the Netherlands, and an island 100 miles off China's coast. The most advanced technology in human history, resting on the most fragile foundation ever built. A century ago, wars were fought over oil. This century, they may be fought over silicon. So here's my question for you. Will America's export bans actually keep China behind, or just speed up the day China doesn't need Western chips at all? Tell me what you think in the comments. And if silicon really is the new oil, this won't be the last empire we investigate. Subscribe, and I'll see you in the next one.